Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 5 of GCP Zero to Hero series, and in this episode we will focus on Google Cloud Storage Services followed by a cool demonstration of GCS. Now before we get started, I have a useful tip for the cloud learners. No matter which cloud platform are you learning, it can be AWS, it can be Azure, or it can be GCP. Do not focus on learning more number of services. Instead, focus on understanding how a cloud engineer integrates these services to build a project in real time. And that is exactly what we are doing in this series. For example, in episode 2, we learned about GCP projects and we learned how to integrate the project resource with the billing resource in AWS so that you understand how in real time a cloud engineer sets a billing account and budget alerts for the GCP project. Similarly, in episode 3, we learned about GCP IAM. We learned how to create a user, how to create roles at the project scope in GCP. In episode 4, when we learned about Compute Engine, we learned how to log in as an IAM user, how to grant permissions to the IAM user to spin up a virtual machine in GCP, how to connect to it, and how to deploy Nginx web server within the virtual machine. Even in today's video, when we learn about GCS buckets, I will explain you how to connect your virtual machine with the GCS bucket using IAM service account within a project. So overall, what I'm trying to explain here, focus on learning services, but most importantly, understand how a cloud engineer integrate these services to set up a project in the organization. Perfect. Now going back, what are we going to learn today? So we will learn about different types of cloud storage services. So within Google Cloud, you have bucket storage service or the cloud storage, you have the file storage, you have PubSub. So we will understand what exactly are these storage services. What is the difference between them? We'll also understand when a cloud engineer has to pick up a service over others. We will focus more on GCS because as a cloud engineer, you might be dealing with GCS on a day-to-day basis. We will understand different characteristics of GCS, such as versioning, auditing, lifecycle policies, RBAC, hosting a website, everything in this video. Of course, there is a demo. As I told you, we will learn how to integrate all the services that we have learned till now using this demonstration. So make sure you watch it till the end. Of course, at any point of time, especially during the demonstration, if you are stuck, I have shared the complete notes in this repository. Head to the Day-5 folder. You can follow the theory and also you can follow the demo, including the commands. You can star or fork this repository if you want to get updates whenever I make some changes. Perfect. Now let's head to the whiteboard and try to understand what are these storage services within GCP. So basically, in the previous classes we have learned, if you want to create a user in GCP, you will use the IAM resource. Or if you want to create a virtual machine in GCP, you will go for compute engine resource. In the same way, if you want storage, you will head to one of the storage services within GCP. The only difference here is that for user creation, IAM is a standalone service, but when it comes to storage, GCP offers multiple services. Depending upon the data that you want to deal with, you have to pick up one of the storage services. But Abhishek, why are there multiple storage services? Can't GCP just provide a single storage service? If you understand from our day-to-day life, or if you see how we deal with data in day-to-day life, you will understand why GCP provides various storage services. For example, If I give you some movies, if I ask you to save some movies so that you can watch them later, probably you will store those movies on your local disk. Or if there is no storage on your local disk, you might go for a SSD on your hard disk. If I share you some code files, you might go for a Git repository and store that on a Git repository. Or maybe if I give you some photos, or if you have captured some pictures on your mobile, you might store that on the Google Drive. So depending upon the data, because all of this is data, this is data, this is data, and this is data. Depending upon the data that you're dealing with, you are choosing the storage service. In the same way, what GCP says, we don't want to enforce a particular service to you. If you want a database like service, you can go for database like service that we offer. If you want to store some log files, you can go for a particular service. Or if you want a shared access, you can go for a particular service. So this is what GCP says. Now, what are these storage services? Okay, we understood there are multiple and there is a reason for it. But what are these storage services? So the first one is cloud storage. This is shortly known as GCS as well. Second one is the file store. Third one is PubSub. And fourth one is basically the data store, or basically big tables. Now let's understand what is the use case for each of them, specifically for cloud engineers. Now, accessing this is not a big deal. You can just go to your Google Cloud project. Let's say when you search for big tables, all that you need to do is search for big table and you will find the big table resource and you can create one. But important thing here is that you need to know when a cloud engineer should choose cloud storage, when a cloud engineer should choose data store, pub file, file store, and also there is something called local SSD. Let me explain. So cloud storage, which is shortly known as GCS, is very, very popular, and this is an object store. So when you want to store some objects, it can be your log files, or it can be your backup scripts, or maybe it can be some of your artifacts like your war file, maybe jar file, anything. You can go for an object store. Object store is the cheapest solution because the data is stored as objects and it is stored along with the metadata. There are more characteristics of GCS, which I'll talk in a couple of minutes. But for now, at this point, remember, as a cloud engineer, if you are asked to store some log files, backup script, or artifacts, go for cloud storage, which is an object store called as GCS. Whereas if you are asked to create, or if you are asked to set up NFS system on the cloud provider, then you just have to create an instance of file store. What is an NFS system? Basically, if you are using your Windows, you might have created some shares, right? Your Windows share. Or if you're using Linux, you might have mounted a volume so that different teams within your organization can share some files. Very simple. If you're working in an organization, your organization might have a specific PPT template. This is a very basic example. I hope everyone understands it. Organizations have specific PowerPoint templates, not the ones that you download from internet. Now this has to be shared with everyone, especially different people within the team. So they can just create a file store and they can put PPTs within the file store so that everyone can access this particular template. Or even a simple example of file store. If you understand Kubernetes, when you have different pods and these pods are stateful sets, then you can use file store across different pods. So both of these pods can share the same data. If you don't understand Kubernetes, you can leave this example for now because anyways, we will learn about Google Cloud Engine And at that point, we will learn more about the file store. Then you have PubSub. PubSub is basically messaging service. This is not typically a storage service, but anyways, it is used to share the messages. So I thought I'll just introduce you to it. But there is a dedicated lecture. I hope that is lecture 9 or 10, where you will learn more about the messaging service. In a nutshell, PubSub has to be used when you want to share, or when your application wants to share a message with a database service or with multiple other microservices within your ecosystem. This is basically like your Java messaging service or RabbitMQ or somewhere related to Apache Kafka. You can create a topic, and within the topic, your application can push a message. Now, data store is used for NoSQL database. So if someone asks you to set up a NoSQL like database setup, then you can go for the data store. And finally, local SSDs. Just as you understand, imagine you have a virtual machine, and if you want to extend the storage of this virtual machine, you can create a block storage, or you can create a local SSD, and you can attach this local SSD to the virtual machine. If your virtual machine is today with 30 GB volume, and if you want to add some 100 GB, so you just have to go for Google Cloud Project, look for local SSD, create one, and attach that to the existing virtual machine. But Abhishek, why cannot I create a cloud storage and attach it? Because for the virtual machines to write the data, you need the block storage, you don't need the object storage. So every storage service is different. You cannot attach, or it's not a right thing to attach an object store to a virtual machine. You need to attach a block store to the virtual machine, and that block store is offered by local SSD. If you want to store huge amount of data, imagine you want to store 100 GB of logs, you should not go with local SSD, because local SSD is pretty costly because of its high performance and block storage type. Cloud storage is a very cheap solution. It comes with latency, it comes with low throughput, but for saving log files, this is the best solution. If you want to share data between multiple teams, multiple pods, or if you want to set up an NFS, you have to go for file store. If you want to set up a messaging queue for your developers, then you have to create a PubSub and share that with your developers. Finally, if you want to set up a NoSQL like data store, something like a DynamoDB, then you have to go for data store or big tables in the Google Cloud Platform language. I hope you understood the requirement, specifically from DevOps engineer's point of view. Now let's discuss more about GCS. We will talk about these storage services as we move to the next lectures, but in today's video, we will focus more on GCS, that is Google Cloud Storage. Abhishek, why is Google Cloud Storage very important? Because you have been telling it, it is basically used for storing log files, or maybe storing some backup, or maybe storing some jar files. But why is it very important in that case? Because GCS comes with very good storage characteristics. For example, as I told you, it's an object store. Object stores are usually very cheap in nature. So instead of buying a physical server, or instead of storing data on the Google Drive, companies can easily onboard this object store. But the most important point, this particular object store or GCS is highly durable in nature. What is durable? Durable means specifically GCS comes with 99.9999 up to 11 nines of durability. So your data is almost never lost. So the chances of losing your data is almost impossible. And how GCS does it? Whenever you spin up an instance of GCS, which we usually call as a bucket. So whenever you create a bucket for your project, imagine you store logs within this bucket. This is set up in a region. Maybe you have set this up in AP South 1, when you create this bucket, GCP replicates this bucket or creates copies of this bucket in different availability zones automatically. You don't have to do anything. GCP automatically replicates or creates multiple copies of this bucket and data within the bucket. So even if one of the availability zone or data center goes down, you still have multiple copies within the different availability zones. So as I told you, the data is almost never lost. This is very important feature. Imagine you have some important files stored in this object store and cloud provider says they are never lost. So you will be absolutely happy about it. Object store itself is a very cheap solution. To make it further cheap, cloud providers, specifically GCP, comes with storage classes. That means cloud provider GCP says you can create a bucket. By default, the bucket is with the standard storage class. But if you feel the data is very less accessed, then you can go for a nearline storage class. So while creating the bucket, you can say, I want to go with nearline storage class. In that case, you can expect little more latency, very low, or compared to standard, you can expect low input, output, and throughput, but the cost will be significantly less. If you feel you have some data that is accessed only once in 3 months, then you can even go for cold line, which is even cheaper in cost. And finally, if you have data that is like accessed once in a year, you can go for even cheap storage class, which is called as archive storage class. So this way, object store is itself a cheap solution and cloud providers aim at making these solutions further cheaper. I told you this is 99.9999% durable. Abhishek, but I want 100%. I work for a bank and I want the durability to be 100%. GCS also provides that. So when you set up a bucket, there is a chance that the complete region might also go down, although that mostly does not happen. But if the AP South 1 region completely goes down, automatically all the availability zones are down, right? There is some disaster in this region and all the availability zones are down. So there is that 0.000000001% chance of losing data. That can also be eliminated if you go for a multi-region bucket or a multi-region GCS solution. This is not available out of the box on AWS, at least to the best of my knowledge. So GCS has this extra capability where you can set up a multi-region bucket automatically, not only in availability zones, but across the regions as well. Your data is replicated. So this way you can make it almost 100%, right? I mean, there are no cases where all the regions are down. So you can technically call it 100% durable. It also supports versioning, just like your Git. GCS also comes up with versioning. So if you have different versions of your log file or maybe different versions of, even you can save your code here, but it's a very less practice solution. But if you have different versions of your log file, you can maintain that here. Or maybe if you have different versions of your database dumps, you can maintain here. And finally, most importantly, it also comes with an RBAC. And this RBAC can be maintained at the complete bucket level, or RBAC can also be maintained at the object level. What do I mean by this? So imagine you have 10 files, okay? Within your GCS bucket, you say you have stored log1, log2, log3, each one for one of the application. And you want log3 should be only accessible to a particular development team. So you can also do it because GCS supports fine-grained policies. So you can set up RBAC at an object level, or you can say all of this is in a bucket. So grant permissions to the developers at the bucket level. You can also do it. Perfect. So RBAC is another interesting characteristic. So these are some important characteristics of GCS, which makes it a very popular storage solution. Whenever someone says the cost is very cheap, organizations usually tend towards it, because if you say a company that okay, you have a lot of data that you want to save, just come to our storage solution, we give it like zero point 0.0 US dollars, 0.015 US dollars per hour, then companies will be very happy about it. And now when you say the company we also offer all of this, they will be significantly happy about it. This is one of the reasons object stores are very popular, not only on GCP. Even if you look at AWS, S3 is a very popular storage solution. If you look at Azure, Blob is a very, very popular storage solution. GCP has an edge when compared to S3 and Blob, that is specifically with respect to default multi-region setup. So this is about GCS and why GCS is a very popular solution. A quick recap: all the cloud enthusiasts or many of the cloud enthusiasts, when they start journey, they are little confused about understanding the storage solutions, like when should they go for a particular storage solution. Go for cloud storage if you are looking for an object store to store random things like logs, backup, artifact, anything that is not something very very significant for your organization, and you just want to use it like a heavy storage for your organization. File store, if you want to share some important files between different teams of your organization or multiple stateful applications within your organization. PubSub for messaging queues, data store for NoSQL database, local SSD for uh, a block storage for your virtual machine, something that is very fast, some like your pen drive, something that is very, or something like your local disk on your laptop, something that is very good at throughput, almost no latency, then you have to go for local SSDs, and these are usually attached to the virtual machines. And then you can just go to the documentation. I would highly recommend this and go through this file called GCS overview, so that you get a very quick recap of the features that I discussed: object store, durability, availability and storage class, multi-region setup, performance, everything that I talked about in the lecture. Now we will go towards the demo. What are we going to understand within the demo? So in today's demo, we will focus on a very simple use case. Almost every company, every cloud engineer must be familiar with this use case. So we will spin up a virtual machine. Imagine a developer is writing a Python application within this virtual machine, and this developer wants to connect this virtual machine to an object store. An instance of the object store is called as bucket, and within this bucket, let's say there is a text file, or let's say there is a log file. So this developer wants to connect the virtual machine and pull this text file onto this virtual machine, or pull this log file on the virtual machine. In day 2 or day 3, I hope you remember, I mentioned when one resource wants to connect to the other resource, then what you have to set up? You have to set up an IAM service account, and you have to assign that IAM service account to the virtual machine. Only then this resource can talk to the other resource. If a human or if a user wants to talk to a resource, IAM user is required. But because virtual machine is not a user, IAM service account is used to interact with the resource. Perfect. So we will start with this demonstration, a very, very simple one. Firstly, we will head to Google Cloud, and on Google Cloud, I will search for, first let's set up a project, right? I don't think I have a project, so I'll click on new project. I'll just call it as GCS demo. Bucket. I'll just say this. Create the project. Okay. Select the project. Perfect. We are within the project. First, we will set up a bucket or just search for storage. So you will see here when I search for storage, I get an option for cloud storage, file store. Similarly, if I search for big tables, I see that option. I want to go with cloud store, GCS, an instance of cloud storage, that is a bucket. Click on create a bucket. And then I'll upload a text file from my local onto this bucket. Okay. One important thing to note here, when you create a bucket, the name has to be globally unique. Understand this. It is not, it should not be only unique within your organization, but it has to be globally unique. Why? Very simple answer. You can also host a static website using this. So whenever you create a bucket, so you get a unique URL for the bucket, and this unique URL can be shared across the globe as well. Okay. So typically what I'm trying to say here, when you put a resource within the bucket, you can also make it public and you can expose it to the entire world. Now, when you try to expose something to the entire world, the name of it should be unique. So I'll go with something very unique like GCS, Abhishek, maybe let's say bucket demo VM. If this is not unique, when I click on continue, it should warn me or it should throw an error. Now, because it did not throw an error, that means it's unique. Choose where you store your data. Okay. Do you want a multi-region bucket which comes with almost no, almost 100% durability? So I would say I'm fine with a single region. I'm fine with 99.11 of durability. And I will go with a region that is closest to me. In this case, Asia South 1. Again, I'll click on continue. Choose how to store your data. If you remember the theory part, I clearly explained you that you can reduce the price by selecting a low storage class. So if I'm with standard, you can see that the storage cost is 0.023 per GB per month. If I make it nearline, let's see what happens. See, it reduced to 0.016. If I make it cold line, I think it should even reduce further. Yeah, it became 0.006 GB per month. The reason is that when you go for nearline, then you get high latency and you also get low throughput because this is best for backups and data access less than once in a month. Okay, so I'll go with standard for now because I'm doing a demo. Permissions, do you want to have public access? It's okay. We are doing a demo. We don't need a public access for it. We just want virtual machine to connect to it. So we'll stick to the normal one, right? So I'll just stick to the normal one, the default option, prevent public access. Soft deletion policy, object version is disabled. If you want, you can enable it. Bucket retention policy, encryption type. Okay, looks like good. Create the bucket, confirm. Bucket versioning is not mandatory. Like only if you want the bucket versioning, you can go for it. Just click on configuration here and you can enable the versioning, right? Like I told, for now, I'm fine with it. I'll just stick to the default configuration. Now, how do you upload files to this or how do you upload data to this bucket? It is very similar to your Google Drive. You don't need any additional knowledge. Just click on upload, upload files, and upload a file from your local. So I've created a text file called gcs text.txt and I uploaded that file. You can upload log file, you can upload any file that you are interested. Select it, you can also download, you can also delete it. Or you can also move the files. Okay. Anyways, I'm perfectly fine with it. I have created the bucket. I have uploaded the file. Because I enabled permissions at the bucket level, if I click on this and if I try to uh, edit access, it says cannot get legacy ACL because you enabled the access at the bucket level. In the theory part, I explained you can either enable access at the bucket level or you can enable access at the object level. This is called fine-grained access, and the other thing is called as bucket access. Now we have enabled bucket access. So here in the permission section, I can select particular users and say that only these people should have access to it. Grant access, and I can say principals or identities who should have access to it. Switch to fine-grained. This is other thing that I explained. If you switch to fine-grained, log file 1, log file 2, log file 3, you can define who has access to which file. Okay. Perfect. Now that the bucket is created, what is the next step? We want to access this bucket file from the virtual machine or the object from the virtual machine. So to do that, we need an IAM service account first. Head to IAM this time. Okay, cool. Within the IAM, look for service account. I think this is the first time we are creating service account. We created IAM user and granted access before. Create service account. Let's call this as GCS demo. I'm fine with the description. I will leave it default. Select a role. What should be the role? It should be storage admin. Storage admin, grant full access of buckets and objects, right? I think this is the perfect one. Grant full control of buckets and objects. Even in the documentation, uh, I have granted the required access. If you go to the, sorry, I mentioned the required access. If you go for the demo section, you will see here the permission that needs to be granted in the service account, storage object admin. Okay, this is also fine. This is storage admin, but this has even escalated privileges. So to have permissions very related to the storage bucket. Okay, I'll just change this to storage object admin. There is no problem if you go with the previous one as well, but that has more permissions. Grant full control over objects including listing, creating, viewing, and deletion. Previous one said grant access at the bucket level. Okay. Right now I don't have the principal because I haven't created the virtual machine yet. So I'll just click on continue and done. Done. Okay. Now this is created. GCS demo bucket. Okay. We have the service account also ready. Now the final step is to create virtual machine. You know, to create the virtual machine, we have to enable the compute engine API. Right? Click on compute engine. Okay, it's already enabled. Good. Create instance. Or is it not enabled? Yeah, enable. And that's what I was wondering because I just created the project. Now it makes sense. Now, once the compute engine is enabled, we are left with one final step. That is to create this instance with as low cost as possible to demonstrate you how to access the files from the virtual machine using G-Cloud. So we will be using the G-Cloud CLI. Okay, compute engine API is still being enabled. So let's provide the name of the virtual machine. Okay, I'll again use the same name, GCS demo. Also make sure you delete these things once the project is done. I'll also show you. First, I will delete or disable the billing, and then I delete the project so that you will not incur any costs. Towards the end, I'll try to show you that. Let's go with AP South 1, nearest zone. I'll keep it as Asia South 1A. We learned E2 family is the cheapest. Right now it's 30 US dollars. See how I'll get it to 4 or 5 US dollars. So make sure you also go with those settings. First thing is I will change this to E2 micro because my use case is very, very simple. Then it already came down to 8. Then I'm not going to change anything here. I'll stick to Debian 10 GB data protection. I don't even need any networking changes. I'll stick to the same thing. In the security, yeah, this is where I will be adding the service account, right? I'll grant this instance access to the service account. Should be somewhere here. Yep, service account, GCS demo. If you don't add it at this point, it's totally fine. But when you want to add later, you have to stop the virtual machine. So try to add it during the creation if that's possible. Okay, this is also cool. I have one setting to show you. Just go to advanced. If you're new to cloud, there is something called spot instances. It should be somewhere here as well again. Yeah, in the provisioning model, instead of standard, go for spot. So you can see now the cost should come down significantly. From $30 when we started, it came to 8 when we went to E2 micro, and now it is 4.14 USD. This is the cheapest instance that you can get probably on GCP to the best of my knowledge. And spot instances, if you are not aware, uh, they are not permanent instances. Like you cannot keep this instance forever. It can be deleted at any point by Google Cloud Platform, or it can be revoked from you. So that's why they are called spot instances. They are very short lived and you don't know the exact life of the spot instance. So handle with care if you're running any stateful applications. This is not at all preferred. If you're doing any hobby or part-time applications, yeah, this is perfectly fine. Now let's say create because we are all good. Okay. So instance is being created. You should see the green color check here at the status that confirms you have the instance. I think we are done with all the steps. If you look at the configuration here, we have the VM, we have IAM service account, which has permissions to talk to the bucket. So let's connect to this instance through gcloud or SSH and run couple of gcloud commands to pull the bucket object to the instance. Okay, let's wait. It shouldn't usually take this much time because we went for a spot instance. Let me refresh and see. Yeah. So yeah, as I told you, it shouldn't take a lot of time because it's a spot instance. Probably it's some issue with the loading. Anyways, so we have the instance. Either connect to it through the SSH, take a new terminal or new browser and or a new window and connect to it. Or what I usually prefer is this Cloud Shell. It's just like your terminal, but it is on the Google Cloud Platform. Just authorize, done. First of all, you don't get authorized to this instance. You just have to run a single gcloud command, which I explained in the previous lecture. I'll show you again. Run this command, gcloud compute SSH, and provide your instance ID. It should be somewhere here, the instance ID. Yep. Copy, scroll up, paste it. Done. So you can also connect to this instance from your terminal, but for that you have to upload a public key. This is more secure approach if you have access to the browser. If you don't have access to the browser, then definitely you can upload your public key, which I'll show sometime later in this series. When we learn about G-Cloud CLI, you will definitely learn about it. Okay, you name -a to confirm we are on that instance. Linux GCS demo. Okay, this is the instance name. Again, we are good. Now, run this command gcloud storage ls followed by name of the bucket. I don't remember the name of the bucket, so I'll just have to search for it. Storage, cloud storage. I'll go for buckets. Okay, so this is the name of the bucket. Copy, and just like how we use the HTTP protocol for buckets, just say gs : followed by the name of the bucket. Right now I'm only reading the file and I'm able to read the file. That means my instance has read access to the bucket or the objects. Now I will try to pull that object from the bucket onto this virtual machine. For that, the command that we use gcloud storage cp followed by this entire thing that we just got. And what should be the name on this local machine? So I'll use the same name, GCS test.txt. Perfect. So it said downloading, downloaded. When I do ls, I have the file here, cat gcs test-text. Perfect. It says my name is Abhishek. Great. So this is how you access bucket from your virtual machine. Try to learn things real time. This is what this is something that I keep saying. Now, even if you're attending interview, you can tell your interviewer, I know how to integrate cloud storage with virtual machine. I've done it for my development team, which is a more valid case. Instead of just saying, I know cloud storage, I know virtual machine, you can just say, this is what I've done. So this is more real-time learning. Of course, I know we just use a simple text file, but you can use log files instead, or you can use any configuration files instead. The focus is not that. Perfect. I hope you found this video informative. Now the final thing is to delete everything. For that, head to billing. Please don't skip this section because I don't want you to incur huge cloud costs. Although we use the basic instance and basic storage with the standard class, but still. Click on manage billing account. Here, you just need to disable billing first. What happens if you don't disable billing and directly delete the project? It's still fine, but you will be charged for some time. So, I mean, why do you take that risk? Instead, first disable the billing associated with the project, then head to manage resources, and here, tada, delete project ID, and now you are good. Okay, you can also go through this. What does this say? So it says your project is scheduled to be deleted. Some resource might be deleted much earlier. Because we disabled billing, we don't have to worry a lot. Shut down. So the advantage of disable billing is that even if you have any billable resource, uh, it will be not accessible and you will not be charged for it. Okay, so we have the project also deleted. So this concludes lecture 5. I hope you enjoyed this lecture. I hope you found it useful. If you have any feedback, please let me know in the comment section. See you all in the next video. Take care. Bye bye everyone.